Welcome, ladies and gentlemen, to this presentation of Evonik, a leading company in specialty chemistry. My name is Frank Lindner, and I'm 32 years with the company. My responsibility is the global market development for Vestenomer in road construction. Today, I would like to give you, first of all, a quick introduction into our targets. Then we'll come to our results of our lifetime prediction, our emission tests, as well as presenting a chance for CO2 reduction in road construction. Let's start with a quick overview about what is Vestenomer in road construction. First of all, we are talking about a global business, but only in Germany alone we have already 160 projects in a list. We can do a calculation of already achieved CO2 savings as we have finished our life cycle assessment in 2020. And what we are very proud about as well is we see a growing scientific interest into our product and the solution of rubberized asphalt containing Vestenomer. We call Vestenomer a most comprehensive and proven solution to improve processing performance and sustainability of rubber modified asphalt, which I would like to explain by some key aspects we are serving. First of all, our solution is ready to apply at any asphalt mixing plant with no changes in the equipment needed. You will observe that there's a very clean handling of rubberized asphalt possible when Vestenomer is added. We serve also easier processing as our product is reducing the stickiness to metal, which is then giving you an easy manual handling of the material. There is a high process safety coming with the use of rubberized asphalt containing our product because the broader temperature window allows you even processing at lower temperature. We have observed in the field that 110 degrees centigrades is no problem in working with the material. And all this results in a very nice and easy way to have secure compaction and therefore best performance of your road pavements. Finally, our solution is ready for any of the asphalt pavements, even to the very extreme challenges of industry properties. For example, like this container property, as you can see on the picture. Climate is no issue for rubberized asphalt containing Vestenomer. If it's really cold or if it's extremely hot, our asphalt solution can serve all the climates. We're monitoring our projects. Some of them are now 16 years old. We can see that still nice performance is there. More about long-term or lifetime prediction would come at the end of the presentation. So let's speak about another aspect, and that is a sustainable approach by the use of secondary raw materials. Together with our product, it's possible to enhance the use of recycling asphalt, and I will give you a slide at the end of the presentation as well as there is the sustainable resource, the secondary resources itself, which gives you a very nice sustainable approach of asphalt paving in a sense of a circular economy. And not to forget CO2 savings. We see a lot of potential in CO2 savings, which is available for the road construction industry, and I will give you some details later on. Not to forget what happens at the end of a lifetime. So every pavement comes to a lifetime anytime. We tested that. And we can say that if we talk about the asphalt properties, or if we talk about the emissions while we would recycle rubberized asphalt with our product, there is no issue. There is no restriction in reusing the material. What I would like to tell you, or what I would like to explain to you today as well, is about a project which we ran last year in October in association with our State Department of Transportation in our state in Germany. And that was about a full replacement of an asphalt package. All 3 layers had been replaced. All material which we are testing are coming really from that commercial production. And most of the testings are based on the splitting tensile strength tests and the cooling test. And the cooling test I would like to present a little bit in detail. We have tested that, as you can see in the picture in the middle, and we are comparing the typical polymer modified asphalt versus the solution containing rubber and Westenomer. What we see here for both the top layer on the left and the binder layer on the right, superior performance comes with the use of rubber. And I have to say, again, we can see these results because this range of 26 to 27 degree minus is what we typically see as a result in our cooling tests. Coming to the lifetime prediction, we are trying to determine the moment in time when you would have a fatigue error in your pavement. That means from traffic, you will have the strength occurring at the very low end of your asphalt package, as you can see on the picture to the right. And then you have this crack, and the crack will grow to the top. And we want to find out and give information of how many years will you get before this happens. We did this with top layer, binder layer, base layer. As I said, all from commercial production. Rubber asphalt was coming from the dry process, and we compare by modification of only the top layer, while the other layers had been unmodified. And we have seen that the prediction of lifetime is equal. So if only modification of the top layer occurs, then the rubberized asphalt solution is on the same quality level. But it changes if you go down and add also the modification of the binder layer, and you have already modified your top layer. And you can see that a longer lifetime can be expected by the use of rubber. And if you do the full modification of the asphalt package, like we see it now, then you see a significant improvement of lifetime on the side of the rubberized asphalt. The splitting tensile strength test, which is base of this study, has been done by different frequencies and by different temperatures. And because we have done that, we can do this prediction for all the different work and construction classes which we have in Germany. And you can see the lower the construction class is, the higher the impact of rubber modification can be observed. And up to 23% extra lifetime compared to the state-of-the-art solution which is available today can be achieved if you go for something like a middle-class construction. What is very important for us as a company, but also what is very important for the industry of road construction, is of course the emission, which are heavily discussed, especially coming to rubberized asphalt. So we did a test here first at the driver of the paver, who had sensor at the body, and we measured the substances which are around the driver. We compare again polymer modified asphalt and rubber asphalt. To make a long story short, the picture we see here is comparable. So there is no disadvantages on the rubber side. We do not see any critical substances, and all the max values which are allowed are no problem for the emissions for both sides, but also not for the rubber. There's one interesting thing, the emission coming from bitumen itself. We have seen a lower emission on the rubber side, something what is not good enough to achieve the 1.5 milligrams per cubic meter, which is the allowed max value starting 2025 in Germany. But again, we have an advantage on our side, and we are studying now to lower the production temperature to further improve the emissions in asphalt. We did also test at the sidewall of the paver, and here the same picture, there is no critical substance. Again, The advantage, as we see it from our studies, is on the side of the rubberized asphalt, but here we can also see that we have reached a level under the new max allowed volume of 1.5 milligrams per cubic meters. And we know that this is the first test, and we have to go further and deeper into that subject, something what we are already planning. And we are planning also to do the emission test at lower production temperatures. What comes with emission is, of course, also the discussion of carbon footprint. CO2 reduction is something what we always hear every day. And during our last year, we had the life cycle assessment finished, and we can now compare the regular solution, the state-of-the-art production of a regular polymer modified asphalt versus our solution as we propose it. What we see is that there is a CO2 saving from a cradle-to-gate approach. That means from starting from the raw materials for the asphalt to the leaving of the material, the asphalt, to the construction site. And this advantages is not including the longer lifetime. So it's simply finishing the production and then see the CO2 saving. This is the asphalt production, but we can go a step further. And let's make a calculation based on the small project which we used for the testings. This is the setup, and in total for the top layer and binder layer, 825 tons of asphalt have been produced and paved. There was a 30% recycling asphalt in the binder layer, which we have to extract from the calculation. So pure asphalt was roughly 676 tons. And from the cradle to gate approach, that means simply from production of asphalt, we already achieved 5.4 tons of CO2 saving. But 6 tons of rubber had been used in this project. And for not burning the rubber, but using it as a recycling material, another 4.2 tons of CO2 saving is possible and has been achieved. And what would that mean for Europe? First of all, we can see that there is an impact from using rubber, and that is coming from the not burning. Not burning the tires is saving 700 kilograms of CO2 for every 1 ton of tire which is going into recycling. We then see the asphalt figures, as we can see on the upper side. We know how much of modified asphalt is produced in Europe in the countries which are listed. And if we take this as a basis, then roughly 290,000 tons of CO2 savings is possible if we would think about fully replacement of the existing solution and turning it into using secondary raw materials. And that means we would not burn the tires, but we would reuse them in asphalt. That brings us the first 290,000 tons of CO2 savings. Plus, the cradle-to-gate approach, as we have seen before, would add another 240,000 tons of CO2 savings. I would like to highlight one last thing here in this presentation, and that is the recycling of asphalt. We do know that there are some limits, especially if we talk about top layers, and we sometimes hear 10 to maybe 12% of recycling asphalt may go into the top layer. But we are monitoring a project which we have finished in 2012, and the order from the authorities was to use the maximum possible of the old pavement going in the new pavement for the new construction. What we have done is a top layer containing 50% of recycling asphalt. The recycling asphalt came from the old pavements. And the pictures you can see on the left side have been taken last year after 8 years of use of this road. And what you can see here is there's still a lot of traffic, even bus traffic. There are trucks going over on this city road. However, what we have achieved is a high-performing asphalt pavement, and we have tested asphalt properties to prove that. Plus, we have reduction in supply chain logistics because we have saved 50% of raw materials, which have not been necessary to bring to the asphalt plant, as it was already there from the recycling and the old asphalt pavement. Due to this, we have, of course, reduction of diesel from the logistics, as well as we have the CO2 reduction from the traffic. Not to forget, less trucks going over our streets. And if we multiply this by the road network of secondary roads which we have in Europe, that is a significant contribution possible only from the logistics, which we measure around additional 500,000 tons of CO2 savings. So this is something what is not within the specifications today, but we believe it is worth thinking about this, and we are hoping to get more chances to go into projects and prove again that more is possible and that we can do more for our environmental protection to contribute to cost saving on the sides of the authorities, to have profitable business for the asphalt industry at the same time. So this would be truly a win-win-win situation. Having said that, I would like to thank you very much for your attention, and we would be very happy to meet you here on our booth at the E&E Congress, or to come into communication with you after this Congress here in the E&E. Thank you very much.
I want to thank you, every one of you participating in this show and this presentation, and I'm looking forward now to answer the questions. And so there are several questions. I will just try to get all of them, starting in the very first one that was from Eric. So how big is the market for Crumb rubber modified asphalt in Germany and in Europe? I would say, especially for Germany, it's still in the one-digit percentage. I cannot be precisely if it's 4%, 5%, 7%, but it's comparable small. However, what we can see is there's a big opening in general. Like in 10 years ago, there was almost zero, and we see more and more openness to the use of rubber. So Shine, he is asking for more details and on the fatigue tests. So not to go into any details, but we used the splitting tensile strength test to measure the stiffness at different temperatures and frequencies from 0.1 to 10 hertz. Then we were taking the fatigue from the splitting tensile strength at 10 hertz, as well as we ran the cool temperature behavior with the cooling tests. Hopefully the picture could explain that, how we run that test. Then we have Ian, how were the emission monitored? Well, we had sensors placed directly on the pavers, on the driver of the paver. So we have a personal emission testings, and we can also see that he was faced to the most emissions from all of the crew. Then we had also censored at the sidewall of the paving machine, and that was collecting then while paving all the emissions, which were then taken to laboratory and gas chromatography. And then we were measuring the substances which we can find. Eric is asking, do we have feedback on the recyclability of Crumb rubber? That was a study which we ran already some years ago. We took the wrap and brought it into the production of fresh asphalt. So we combined fresh asphalt with Crumb with wrap using the parallel drum. We have a comprehensive report on that, which is not only explaining the properties of the asphalt, but also we were checking the emissions, and in both cases we can see that there were no issues. So we say recyclability is possible, plus you will not lose quality. In fact, the report, as we have seen, is bringing extra quality to an asphalt containing wrap. Now we have Karin. What was the application temperature during paving? Material arrived at roughly sharply under 170 degrees Celsius. We did not have a long distance from the mixing plant, so we had the original temperature of 170 degrees Celsius, and the paving then took place at around 160 degrees Celsius. What was the application temperature during paving? I think that is then also the answer. So 160 degrees Celsius and dropping because it was October, it was a cold and windy day, and it was dropping as well. Yes, to Michael, we had the same temperature for rubber modified asphalt as for polymer modified asphalt. Unfortunately, we tried to reduce further on the production temperature in rubber asphalt, as we believe there's room for it. We believe we can lower the temperature, but however, before an asphalt mixing pan can really adjust the temperature, it takes some time. So finally, it was only 1 or 2 degrees Celsius under the polymer modified asphalt. We are preparing right now a trial, again in association with the state DOT, where we are targeting on 160 degrees Celsius as a production temperature, as we already know that the compaction at really low temperature like 130, 125 degrees Celsius is no issues. That really comes from the use of the stenomer, as it is lowering the viscosity of the mix. So then Ian, emissions monitoring also doesn't mention particulates. Is there any data on this? Ian, I have to apologize. I do not understand that question, but I would be very, very open, and I would appreciate if we could have a talk on that so that I can clarify that for you, so that you can get your satisfying answer. In which countries are road authorities most interested in carbon footprint information? That is a question from Christina. I would say it's more Central Europe where we see a focus on that. We have discussions elsewhere in the world, but not with that high interest as we have it here in Europe. If there is any country in a certain lead, I cannot say that really. Maybe the Scandinavian countries are more interested in the carbon footprints, but I would also see Germany is really paying more and more interest into that. And in general, it's really Europe where we can see a focus on carbon footprints. Yes, to Carsten, the stenomer contribution to CO2 is included. So we have really a cradle to gate. That means all the raw materials to the production of the hot mix asphalt. Everything is included, and that means also the stenomer is included. There are savings by not burning old tires, but to get a clear and complete picture in your calculation, you should include the emission which are produced using other stuff which are used to substitute the tire burnings to make some energy. Well, Bernd, it's not really clear what you mean with this. If we take out the tires from the burning, of course, there is another raw material coming to replace then the tires. What we see, especially in the cement kilns, there is a change within the mix of fuels. First they used coal, now then they had the tires. Tires are really replaced now broadly, and they are using plastics. But does that play any role in that calculation? I would be very happy to discuss this with you to clarify really on that point as well. Well, here's Mart Aruso. He's asking for the contribution of CO2 from the rubber granules. Yes, that's true. That's mostly coming from electricity, and of course the carbon footprint coming from the production of electricity. That is included in our life cycle assessment. I have to say by heart, I don't have the detail, but the contribution of that is really minor, very minor. Did you ever had complaints on order of the Crumb rubber modified asphalt from the neighborhoods and the roads? Well, actually, what you see is there still is a very, very little odor or a smell where you can realize that there is rubber incorporated, but it's very, very small. That was also confirmed by the authorities from the state DOT from the latest project which we presented today. The Stendimer is acting in two ways. First is coating around the ground tire rubber particles. So that is helping with the emissions and the smell in first place. And secondly, the Stendimer allows to significantly reduce your temperature in production. So you're not running the 180 to 190 degrees Celsius, which you typically hear when people are talking about rubberized asphalt. 170 degrees Celsius are safe, and we believe we can further go down under 170 degrees Celsius. And we know a reduction by only 10% has significantly influence on reduction of emission and then, of course, as well on smell. Oh, here's an interesting statement from Tibor. Thank you very much. 3,000 to 4,000 tons Crumb modified asphalt a year. Thank you. So right now there is no further question, but we still, I believe we have some time. So please let me repeat that this was only concentrating here on lifetimes and emissions, but we have a lot of data which we are very happy to share with you to bring clearer to you the benefits, the flexibility you can get as an industry, the high performance you can achieve. And I would really enjoy if I can discuss with you the concept on how we can increase the use of REP, including also top layers, which for me personally is really one of my favorite, as this is really a win-win-win situation for the industry, for the authorities, of course for us as we can sell material, but also we can do something good for the society and for the environment. So this is really a great thing to do, and we would be very happy to cooperate with you in that field. So we have 3 minutes or 2 minutes remaining right now. I want to thank you again very, very much for over 120 participants in this presentation. And I'm looking very much forward to more discussions to you. And I wish you all a very nice last day on this conference. Thank you to Eurobitume and EAPA for organizing that. It cannot replace a personal meeting conference, but it's so great that we have this chance here. So thank you very, very much for this organization.